Here are the solutions to angles of elevation and depression. So look at number one. A 20-foot ladder leans against a wall so that the base of the ladder is 8 feet from the base of the building. So we're going to draw a ladder leaning against a wall. And you can see the right triangle here, right, that we do from that. And then once we have that triangle drawn, we're going to label it. So the ladder is 20 feet. The ladder is 8 feet from the base. So the base is the bottom right here. And the question is, what is the ladder's angle of elevation? That's there in the corner, the angle looking up. So I'm going to circle this angle and recognize it's adjacent and hypotenuse. So adjacent and hypotenuse. So I recognize that it's cosine. To find a missing angle, it's inverse cosine, that little -1, and it's going to be 8 over 20. And then use your calculator. So inverse cosine, 8 over 20. So that angle, I'm just going to round to 66 degrees. And I won't make you write sentences here. A 50-meter vertical tower. So I'm going to draw a tower, and that tower is 50 meters. Is braced with a cable secured at the top of the tower and tied 30 meters from the base. So here's a wire, 30 meters from the base, that's down here. It's tied there at the bottom. And it says, what is the angle of depression from the top of the tower down? So we're going to find this angle. So this angle up here, the angle of depression looking down. So this is opposite and adjacent. So SOHCAHTOA, that's going to be tangent. So that angle there is going to be opposite over adjacent. Use your calculator. So inverse tangent, opposite over adjacent. And you get about 31. Now here's the thing you have to do. The angle of depression is not inside, it's outside the triangle. So to that answer, you have to subtract 90, and the actual angle of depression is 59. So whenever we're dealing with the angle of depression, part of the question is going to be subtracting 90, because the angle of depression is not inside the triangle. So we find the angle inside the triangle, subtract 90, and we have our answer. Number 3, a point on the ground 50 feet from the foot of a tree. The angle of elevation to the top of the tree, and so here's my right triangle. So down here at the bottom I know is 50. The angle up to the top is 53, and I want to know how tall that tree is. So I circle the angle. This is opposite and adjacent. So again, opposite and adjacent. And then I set up an equation. So tangent of this angle is equal to opposite over adjacent. And then recognize, because x is in the top, we're going to multiply. So we're going to multiply 50 and tangent 53 and see what answer we get. 66. So the height of the tree is about 66 feet. From the top of a lighthouse, 210 feet high. So this lighthouse is 210 feet high. I can already see the angle of depression down to the boat. So I already see this triangle that's going to be formed here. So the angle of depression is outside the triangle. So the first step is to subtract 90, and that's going to be 63, and that's going to go inside the triangle there at the top. 63? Yeah, 63. All right. And then it says the lighthouse, find the lighthouse, the distance from the boat to the foot of the lighthouse. So this here at the bottom. Find that distance, the boat to the bottom of the lighthouse. So circle the angle. That's opposite and adjacent. So opposite and adjacent, again, is tangent. So we write down tangent of 63, and it's x over 210. Because x is in the top, we multiply. So it's 210 times tangent 63. So I get 412 feet. Number 5, Richard's flying a kite. The kite has a string, has an angle of elevation of 57 degrees. Richard is standing 100 feet from the point on the ground directly below the kite. So directly below the kite, there's my right triangle. This here is 100 feet. The angle up is 57, and we want to know how long the kite string is. So that hypotenuse is the kite string. So circle the angle. This is adjacent and hypotenuse. So adjacent and hypotenuse. So which trig ratio uses adjacent and hypotenuse? That's cosine. So we write down cosine of 57 is equal to adjacent over hypotenuse. Because x is in the denominator, we're going to divide. So we're going to go 100 divided by cosine 57 and write that answer down. You get 184. An airplane rises vertically 1,000 feet over a horizontal distance of that. So here's a plane rising, and I'm going to draw a right triangle. So vertical is this number, horizontal is this number, and then this is the angle that I got. So we got vertical, we have horizontal, and this is the angle I'm looking for. So that's going to be tangent, opposite over adjacent, and that's opposite over adjacent, and then use your calculator. So that's 1,000 over 5280. I get 10.7, or about 11 degrees if you round up. The person's at the edge of the river, wants to find the angle of depression down. Now the angle of depression means that you have to subtract 90. So that angle is going to be 43. I see this angle right here. I see this triangle. So this angle inside the triangle, in terms of it, it's actually like this, is going to be 43 in here. I want to know this with 230 here, how far down the river is. Circle the angle. Again, it's opposite and adjacent, so that's going to be tangent. So we're going to write down tangent of 43, and it goes opposite over adjacent. We're going to divide, so it's 230 divided by tangent 43. And I get 247. Number 8, the angle of elevation from a car to a tower. So again, you don't even have to draw the picture in terms of a car. So here's the car to the tower. The angle of elevation is inside the triangle. The tower is 150 feet tall. How far is the car from the tower? Again, opposite and adjacent. Most of these are tangent questions. So opposite over adjacent. We're dividing because x is in the bottom. So 150 divided by tangent 32. And I get 240. All right, turn the page. A radio tower that's 200 feet tall casts a shadow that's 75 feet long. There's my right triangle. What is the angle of elevation? Right here, up to the sun. Here's the sun. What's that angle up to the sun? So again, circle the angle, opposite and adjacent. So that's tangent. So opposite over adjacent, and then use your calculator. And I get 69. The escalator from the ground to this is that. So we have a triangle here. It's already been labeled. I want to know that angle. This is opposite and hypotenuse. So opposite and hypotenuse. So which one uses that? So we're going to use inverse sine for opposite and hypotenuse. That's 32 over 110. If you flip that fraction around, it would be an error message. So 32 has to be on top. And you get about 17 degrees if you round it. All right, I won't make you do number 11. A ladder, we can do this one. A ladder on a fire truck, I can see, has its base 8 meters above the ground. So you can see where the 8 is. We're going to make a right triangle right here. The ladder's 100 feet. The ladder's greatest angle of elevation is 70. So how far up the building, right? The highest above can it be? So this x there is what we're looking for. And then we're going to add 8 at the end. So this is opposite over hypotenuse again. That's sine. So we're going to write down sine 70, x over 100. I'm going to multiply And then whatever answer I get there, so I'm going to go 100 times sine 70, that's 94. I have to add 8 to that. So I'm going to add 8, this part here, then to get 102. And there's my answer. So up to here is 94, and then I have 8 more I add, so I have it all added up. Number 13, I'm not going to make you do. And then number 14, electronic instruments on a treasure hunting ship. So the angle of depression down here. So that angle down there is 29 degrees, 1400. And then it says how far below? This right there, how far down is that treasure? Circle the angle. This is going to be opposite and hypotenuse. So that's x over 1400. So go inverse sine. Oops, I didn't mean that. I meant x sine 29 is equal to x over 1400. So because x is on top, I'm going to multiply 1400 and sine 29. I'm not looking for an angle. So let me clear it up. 1400 sine 29. And I get 679. And you have your answer. So great job doing your work. I'm proud of you. Mr. G Math. Over and out. Till next time.